So Licia, please.
Yeah, thank you very much. Good day, everyone. I am Licia Felicioni. I am from the Czech Technical University in Prague. I am a PhD student there. And since January 2021, I am working on the Work Package 5 task that is related to the assessing the impact of various types of radon protective and remedial measure on the environment. So gas radon is the main source for exposure to ionizing radiation for humans. Indeed, a continuous exposition to this gas can lead to high risks such as lung cancers. The gas radon is in the soil and change soil by soil because it depends from the permeability of the soil or its composition. But in any case, it can penetrate the building through different ways. For example, by cracks and fracture in the floor, cavities in the inner walls, sewerage, and also in a small amount from building materials and water. So since we are living and working in buildings, it is very important to keep a low radon concentration indoor in order to avoid future problems. So the first step that we have moved so far in our research is making an overview of radon risk mitigation measure using in dwellings. Then we have drawn different scenarios of this radon risk mitigation measure. Then we have collected some environmental product declaration that are some document available online in some life cycle assessment database that are open source database. And these declarations are used for assessing the embodied environmental impact for product or more in general, also building components, material, and so on. And the last step was using this environmental product declaration and its environmental impact to running the life cycle assessment. The life cycle assessment, it is a methodology used worldwide for assessing the total embodied impacts of certain products, building components and material, but also in general for buildings. So as I just mentioned, life cycle assessment is composed by life cycle stages that runs from product stage to the end of life stages up to the recycling phase. But in our purpose, we are focused on the product stage and more specifically for the A1 to A3 stage that is known as cradle to gate phase that goes from the extraction of the raw material to the transportation to the factory up to the manufacturing of the material itself. These cradle to gate stages are collected, the impact of these stages are collected in the environmental product declaration. And for example, some of them are written below and are the non-renewable primary energy used for extraction of that raw material, transportation and manufacturing. It is divided in non-renewable and renewable primary energy. Then there is also the use of the net fresh water, and then it goes to the carbon impact and, for example, for the global potential. We have run the life cycle assessment not on the whole building, but we have focused on just the foundation of a specific building, and more in particular on the floor foundation. We have drawn different scenarios. Today I am going to show you just a few scenarios that we have drawn among the one that we are doing right now. The one that you are seeing right now here are passive solution for new buildings. The first scenario, the scenario A, it is also called as reference because it is a scenario that will be compared against the others for understanding the additional embodied impact that radon-proof solution can have on the environment, since this reference scenario doesn't contain any radon measure. Scenario B add one radon-proof membrane. It is highlighted in yellow, like the other measure after. This radon-proof membrane is located between the thermal insulation and the blinding concrete. Then scenario C present always this added radon-proof membrane, but the characteristic is that in the gravel layer, in gray you can see, there are laid down some drylet tubes that are linked to one exhaust vertical pipes that goes through the building up to the roof, and it works as an outlet. So that's make it possible the extraction of the radon concentration at this level. And then scenario D present always the radon-proof membrane, but there is an additional thermal insulation layer that is necessary because at the corner of the buildings are located some inlets that are aimed to bring the outdoor air at that floor layer for start the natural ventilation on this air gap. The air gap is also filled with some preformed plastic components that are igloos, are called as igloos, and also in this case there is an exhaust pipe that runs through all the building up to the roof. So I wanted to show you some first result. As you can see here, we have analyze the embodied energy, like both non-renewable and renewable, and also like carbons, like global warming potential. And from scenario A to scenario D, there is an increasing as of embodied impacts as more protective elements the measure contain. The next step in our research will be drawing scenario for active solution for new buildings. We have already started to do this phase, like drawing scenario with roof fan, inline fan, and radon sumps, always like in the gravel layer or outside the house. Then drawing scenario for different type of the same material. For example, previously I have mentioned always a radon-proof membrane, but I didn't specify which kind of radon-proof membrane I was talking about, because it was in general, but we will assess the impact of different kind of, for example, membrane, gravel, and concrete to understand which one is the most environmental friendly. Then we will draw a scenario for corrective solution for existing building, both active and passive solution. And last but not least, of course, we will run simulation for the life cycle assessment at the floor level for the cradle to gate stage. Thank you very much for your attention.
Thank you very much, Licia. Can you stop sharing?